All right, so today we're going to build on what we worked on in 6th grade, which was area of a composite figure. And these down here are composite figures. So what do we mean by a composite figure? Looking at those, what do you think that we mean by area of a composite figure? Different shapes pushed together, all mushed together. So like this looks like an ice cream cone. And so what are the shapes that we put together for that one? Half of a circle, right? That's important to note that that's not a full circle. It's going to be a half a circle when we continue that radius and show the diameter there. That's just half of a circle. So we're going to have to keep that in mind. Here, what do we have? We have a triangle and a rectangle and a trapezoid. Okay? And over here we have a triangle, a specific kind of rectangle. A square, because, right, 7, 7, 7, 7, that makes it a square, right? It's a specific kind of rectangle. And what's down here at the bottom? Look at up here. It's a parallelogram, right? So, how do you think we're going to find the area of any of those shapes? So, like if I were going to find the area of the ice cream cone, that looks like an ice cream cone to me. How am I going to go about finding that? So, let's not get that specific. So, let's think about what we did last year. You have to find the area of the top, the half of a circle. And then we're going to find the area of the triangle. And then when we know the area of both of those, what are we going to do? Add it together, right? So up here where it says to find the area of a composite figure, we're going to say find the area of each shape and then add all of the areas together to get a total. So to find the area, we're going to find the area . Find the area of each individual shape, and then add all of the areas together to get a total. That's how we're going to do it. That's what we did last year, and that's what we're going to do this year. So, thinking about these shapes right here, how is this different than what we did last year? Did we not do all those shapes last year? The only one that we did not do was circles. No, we did everything except for circles last year. So, right here we did a rectangle and a triangle. Here we did some rectangles and some squares. And then we did these. Do you not remember doing these last year? And even right there is even a little trapezoid that we had to subtract off. So we have done all of this before. The only change is this year we learned area of a circle. Other than that, we have done all of these. So let's go through and let's write the formula. So how are we going to find the area of a square? Does anybody remember? How do we find area of the square? Do what? Base times height, or length times width. But I'm just going to use base times height. The bottom times here, or length times width. All right. Rectangle. Anybody remember that one? Same thing. Area equals base times height. All right, parallelogram. Anybody remember? Oh, what's up?
Wait, how is it a rectangle, a square, and a square is a rectangle?
All squares are rectangles. So every single square is a kind of rectangle, but every single rectangle would not be a square, right? Some rectangles like these are not all 4 sides are the same length. So all squares are a rectangle, but not all rectangles are squares. Does that make sense? So SpongeBob SquarePants could also be known as SpongeBob Rectangle Pants, right? So that could be his AKA if he was trying to go on the down low. All right, parallelogram. Anybody remember parallelogram? So here's what we did. We did an activity last year, think about it, where we cut it off right here. And what did we do? What did we do with this that we cut off? We picked it up and we moved it other side and we made it a rectangle. So we proved, does it have the same formula as a rectangle? Yes, we proved last year that it is still area equals base times height because we can cut that part off, add it over there, and then we have a rectangle. If you weren't in our class last year, sorry, we had fun. Y'all did. We did. Y'all didn't. I don't know if you did or not. Anyway. All right. So then we did an investigation last year on a triangle. I don't know if you remember or not. Here's my handy dandy piece. So here is our square. We measured. Do you remember measuring? And we found this is 3 inches and this is 3 inches. And 3 times 3 is 9. And so we proved, you can't see the picture really well. Will you get the light? At least just the front. Flip the light switch until we see which one. Nope. Okay. Okay. Let's try that. Did that work?
Maybe you should turn off the light and use a flashlight.
Okay. Try turn off both lights. Let's see. Oh, there we go. Look, there it is. All right. So we measured. It was 3 inches times 3 inches. And so what's the area of this one? 9. Right? And we should see, still it's not great, is it?
Use a flashlight on your phone.
Is that, would that work?
Yeah.
Or are y'all just trying to be funny?
That would probably really work. If you put it under, if you put the paper on top of the flashlight, it'll shine better.
I hope you can edit it. Maybe it's the cover of the paper.
I think it probably is. All right, so anyway, oh, can you see it a little bit there?
Yeah, you don't have a microphone on.
It's laying right there.
Oh, okay.
It's okay. Okay, so there's 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, let's see. We're going to turn this back on. So then we took, I guess turn the lights back on, would you please be my assistant? So we took that, and it's 9 squares, and we folded it over, and we made a triangle. But the base is still 3, and the height is still 3. So do you see 9 there?
Yes.
Where you don't see 9 there.
No, I don't.
Because there's a whole bunch missing over here. So what did we decide that we had to do when you had a triangle?
You gotta count the squares?
No, we can get there mathematically, but the formula is a little bit different than this. So we're still going to multiply the base and the height, but we have to take half of it off. How do we do half of base times height? What's mathematically do we do if we say 1/2 of base times height? What does of mean?
Oh, times 1 over 5. 1 over 2.
1/2 base times height. Now, last year, because we had those calculators that were not as good as these, we changed 1/2 to 5/10. Or some of you said base times height and you divided by 2. Our calculators this year will handle this. And I think, let's look and see what formula they're going to give us on Georgia Milestones. On Georgia Milestones, when you check the formula sheet, they're going to give us 1/2 base times height. So that's what we're going to use this year because our calculators will handle it. And this is the formula that we're going to be given. So remember, we learned last year that we have to take half of the base times the height. All right, trapezoids. Who remembers trapezoids from last year? So let's think about it. Ooh, that was a terrible sound. I'm sorry. I apologize. Okay, so remember, we could not just use one shape. So we had to think about it as two shapes. And we had to put them together, and we made a, what is that? A parallelogram. So to make a parallelogram, we have to say base 1 plus base 2. So I can really think of that as base 1 plus base 2 because this is going to be the same as this. Okay, and then it's a parallelogram. So once I know that these together, then I'm going to multiply it by the height, right? Base 1 plus base 2 times the height. But I only want one of them, so then I have to divide by 2, right? Because I'm going to split it back apart. So let's think about that again. Base 1 plus base 2. Now I have a parallelogram times the height and then divided by 2. Do you remember that from last year? All right, so let's think about what that's going to look like. Area equals, let's put this in parentheses, base 1 plus base 2 because we want to add them together first. And so to tell it to add together first, we have to put them in parentheses. And then we want to multiply that by the height. And then the last step is divide by 2. That's going to be our formula. Okay, and then we just learned the formula for area of a circle. Anybody remember?
3.14 times r.
Let's not call it 3.14. Let's call it by its math name. Pi r squared. Let's double check. So on Georgia Milestones, you're going to use your formula sheet. Go to area. Area of a circle is pi r squared. Pi r squared. And I want you to write pi instead of 3.14 because I always want you to write the pi because you won't always use 3.14. You will this year, but we still need to think of that in the right way. So now we've got all of our formulas that we're going to need for the work in this section. Any questions on any of those formulas? All right, so let's look at example 1. Example 1. So we're going to break that into 2 different shapes. And what did we say we're going to break them into?
Circle and then triangle.
Yep, a half of a circle. Let's be specific. It's a half of a circle and a triangle. Okay, so I can split that all the way across. Which one do you want to do first? Well, so we want to do the triangle first? Okay, so I want you to always write the formula. So the formula for a triangle is 1/2 base times height. Write that down and then use substitution just like we were talking about in our warm-up. So 1/2. Now, the base. What is the base of this triangle?
5.
So you're just saying right there is the base of that triangle?
I'm saying 10.
I think it's going to be 10 because we have 5 over here and we have 5 over here. 1/2 of 10 times, and what's the height? 8. 1/2 of 10 times 8. And 10 times 8 is 80, and half of 80 is 40 inches squared. So we can say that this is going to be 40 inches squared. All right, now let's think about what is going to be the formula for area of the circle. We're going to say pi r squared, but since it's a half of a circle, what do we have to do to our formula? Divide it by 2. So now let's use substitution. Pi is 3.14. What is the radius? Remember the radius is half. So it's 5. 5 squared. So pi times 5 squared. Do that on your calculator. 3.14 times 5 squared. You may get your calculator. If you're like me, I forgot mine too. All right, so 3.14 times 5 squared. And we get 78.5, and then, and then we have to divide it by 2. Divide by 2, and we get 39 and 25 hundredths. So this is 39 and 25 hundredths inches squared. And so now what do we need to do? Add them together. So 40 plus 39 and 25 hundredths. $79 and 25 hundredths inches squared is our answer for that one. Ooh, that was super fun. Because how many things were we multiplying together? We're talking about 2 dimensions. We're talking about the space from here to here and from here to here. We're talking about a 2-dimensional figure. Okay? Does that make sense? Okay. Remember, when it's volume and we fill it up in 3 dimensions, length, width, and height, then it's going to be, our answer is going to be cubed. But area is always squared. That was a good question. All right. Are we ready to go on to the next one? Okay, so we have what kinds of shapes? We have a triangle, a rectangle, and a trapezoid. All right, so let's start up here with the triangle. So again, it's 1/2 of the base times the height. 1/2. Now, what's the base of this triangle?
18.
I'm going to go all the way down here.
15.
It's going to be this one. Okay, so the base is 15, and the height is, what's the height of that triangle? 9. Do this on your calculator. 1/2 15 times 9. And you get 1/2. Now, if it was multiple choice and your answers all had fractions in it, you could leave it like that. If it doesn't, I can change it to a decimal using this fraction to decimal. So second, fraction to decimal, 67 and 5/10 centimeters squared. 67 and 5/10 centimeters squared. All right, so we're 1/3 of the way there. We have 2 more shapes to do. Next, we have a rectangle. So our formula is just base times height. Our base is 15. 15, and our height is 4. We should be able to do that in our head. Beginning of 6th grade, I told you knowing your multiples of 15 is helpful. 60. 60 centimeters squared. Right, last one. Area of a trapezoid is base 1 plus base 2 times the height divided by 2. Base 1 plus base 2 times the height divided by 2. So base 1 is 18. Base 2 is 15. We're going to take that, we're going to multiply it by the height, which is 4. And then we are going to divide that by 2. Do you think we need to use, on our calculator, we need to use our parentheses? Yes. 18 plus 15 times 4 equals divided by 2. And your answer is 66. 66 centimeters squared. And now how do we find the area of the whole thing? Add them all together. 67 5/10 plus 60 plus 66. $193 5/10 centimeters squared. Is that correct? Sure, wherever you want to put it, it's your notes. As long as you show it. Yep, 193 5/10 centimeters. Is this coming back to you? Yes. So remember, make sure that you are being careful showing your work so you can go back and look at it if you need to, because these can get confusing if you are not intentional with showing your work. All right, what do we have in this last one? And a parallelogram, okay? So let's start up here with the triangle. 1/2 base times height. So 1/2, what's the base?
The base is
7. And the height is 4. And remember, depending on the shape of the triangle, you're looking for something that goes from the base to the tippy top corner. So remember, on a right triangle that looks like this one is going to be your height, one of your sides. But on most of them, your height is going to go from the base straight up. This does go from the base straight up, but a right triangle is the only one that does that. All right, so 7 times 4 is 28, and half of 28 is 14. 14 yards squared. All right, and then the formula for a square is just base times height. So 7 times 7. And 7 times 7 is 49. I don't want to write that there. Equals 49 yards squared. And then this last one is a parallelogram. And so that is also base times height. And what's the base? 7. And the height is 3. And so it's 21 yards squared. And what do we need to do now? Add. 14 plus 49 plus 21. 84. Is that correct? Yes. 84 yards squared. Those are fun. You just have to slow down and pay attention to what you're doing. And use, what are we going to use here when we write the formula and then we rewrite it? Yeah. I feel like I've said that about 47 times today. Okay. So let's get this ready to put it in our journal. It looks like we're going to fold up the example sections here. You can cut them apart if you want to. I don't feel like I really want to. But if you open it, there's your examples. And then up here at the top are going to be our formulas. So, area of composite figures. What do you think this page is going to be called? Very good. And what page does it feel like we're on?
90. I said 98. I said 98, but it's 99.
It's 99. And it's probably going to be a few pages after that as well, but let's just put 99 in there right now. Area of composite figures. Area of composite figures on page 99. I don't know, we should have one soon, shouldn't we? We've had one all year.
I'm not really convinced that I don't have a page because I was absent and I skipped it.
Okay. All right. So glue that on page 99. And glue that on there. And so your assignment for the rest of class and for your homework is to complete these 6 problems. 1, 2, 3, 4, 5, 6. No cheating in getting your 6th grade journal. We did these last year, so they should be somewhat familiar to you unless you were not in my class last year, and then we're sorry. But work on those. They're due at the beginning of class tomorrow.
Wait,